Having discussed the bacterial anatomy, let us now start off with two important topics, that is bacterial shapes as well as the bacterial physiology. I'll quickly go through the shapes once, that is the cocci, which are the cocci which are present in clusters. And when I say clusters, I mean grape-like clusters. They are going to look exactly like a bunch of grapes, and that means Staphylococcus aureus. In fact, guys, if you look at the name of Staphylococcus, the word staphyle means bunch of grapes. So Staphylococcus aureus is going to look like a bunch of grapes, which is the one that is going to be present in chains, and that is going to be Streptococcus. Especially when we are talking about Streptococcus pyogenes and all, because there is a Streptococcus which can be present in pairs like this, and when it's present in pairs of two, we call it diplococci. And diplococci can basically be a kind of Streptococcus which is known as pneumococcus. There are many others also that can be present in the form of a diplococci, I'll tell you. So now the difference is that diplo means 2 2. So pneumococcus is going to be present as pairs or 2 2 together. If those 2 2 end up being something like a kidney, for example, they are also diplococci, definitely they are two, but they are like kidney shaped, then you're going to call them Neisseria gonorrhoeae. So how do I learn this? I'll tell you. Neisseria gonorrhoeae is going to be starting with a G, right? So we have lots of Neisseria. The G wala, you're going to write a straight G and you're going to write an inverted G. So that will straight away remind you that this is going to look like a kidney. Whereas now if I write Neisseria meningitidis, what am I doing? If I'm writing Neisseria meningitidis, I will write the M over here. If I write the M like this, it looks like a lens. I can make a lens over here and a lens over here. So Neisseria meningitidis is going to look the M, that is lens shaped, and gonorrhea is going to look like a G, that is going to be kidney shaped. Similarly, so can I say this is also a diplococci, this is also a diplococci, and pneumococcus was also a diplococci, but their shapes are different. Now coming to cocci in tetrads, 1, 2, 3, 4, and that is going to be micrococcus. Micrococcus is going to be in a micro cluster of 4. Whereas if there is a cluster of 8, octate, that is known as Sarcina. So remember, Sarcina is going to be ends with A, so Sarcina is going to be 8, or you can learn Sarcina ka S is going to be converted into 8. So Sarcina is octate cocci. Coming to the last one, spectacle shape, the one that starts with E, that is Enterococcus, that is going to be converted into a B. So remember the E of the Enterococcus, I'm going to make it look into a little bit of a spectacle. So wo E ka, we make a spectacle out of it. Let's do a recap. The cocci in grape-like clusters, staphyle means grape, Staphylococcus aureus. But if I make the clusters very chota tetrads, they are chota clusters, micrococcus. If I make it into 8, Sarcina is going to look like 8. Finally, if I say that they are present in pairs, that is diplococci, that is pneumococcus. But if the diplococci are looking lens like this, it is Neisseria meningitidis. If it's looking like a kidney, it becomes Neisseria gonorrhoeae. Finally, if it's looking like a spectacle, I call it Enterococcus. And the last thing is, if it is present in the form of a chain, it is going to be Streptococcus. These were all the cocci that I was talking about, all cocci. Now I come down to all the bacilli that you have to know. So the first one that we have is the bamboo stick appearance. Please note, bamboo stick is going to be seen in Bacillus anthracis. Bamboo stick is going to be seen in Bacillus anthracis. Remember B and A for bamboo stick, for B and A for bamboo stick. Next, which are the diplobacilli, the two bacilli that are going to be together? That is going to be Klebsiella pneumoniae. That is going to be Klebsiella pneumoniae. So now I realize that this pneumoniae always tends to occur as a diplo. When I was talking about pneumococcus, pneumonia wala coccus, that was a diplococcus. Two cocci were occurring together. Now when I talk about bacilli, Klebsiella pneumoniae, two bacilli are going to occur together. Next, which of them is going to be branching and filamentous? So remember, there's an entire family which is referred to as Nocardia and Actinomyces. Nocardia and Actinomyces are going to be branching and filamentous. Which of them are going to be curved like this? So curved may, number one we have Vibrio, And next we have the bacters. What are the bacters, guys? You will study it later. Campylobacter, Helicobacter. So the bacters come here. Spiral, the word only tells me that the family spirochetes are going to be spiral. And what are pleomorphic? Jinka koi shape nahi hai. For example, Haemophilus influenza, Brucella, these are the ones which are going to be pleomorphic. This is just a quick overview because this will help you a lot in your bacteriology section. So first I have told you all the different shapes of cocci and bacilli. Now I'm going to start off with the physiology, and the first thing that I want to tell you is what is a population doubling time. Means from 1 the bacteria becomes 2. So if there are 2, how much time will it take to become 4? So how much time is it taking in doubling? That is going to vary. So for example, for E. coli that hardly takes 20 minutes. But for TB, that takes 20 hours. And for lepra, it takes 20 days. So there is definitely, you don't have to learn. Actually, no one's going to ask you this. I'm just telling you that every bacteria has a different time for becoming doubled up. But for doubling up, we also need to know what is the difference between total count and viable count. See, when a bacteria is dividing, some of them will be living bacteria, some of them will be dead bacteria. So total count means living and dead combine. If you combine the living and the dead bacteria, that's your total count. But what do you think will be your viable count? Viable means something that is living. So viable count will only be the living bacteria. Repeating, total count is a total of living and dead. Viable means viability, only living. So what does it need to survive? It definitely needs oxygen. One by one I'll pick up all of these. So some of them will require oxygen, some of them will not. Some of them will require CO2, some of them will not. So for the time being, let me tell you that one that uses CO2 is going to be Campylobacter. Capnophilic means CO2 loving, and that is going to be Campylobacter. Whereas what about oxygen? So either they will need oxygen or they will not. So first I would want to tell you which are the organisms that are going to require oxygen. Which are the organisms that are going to require oxygen? So oxygen matlab breathing. So the mnemonic is something to do with breathing. Must let nagging pets breathe. I know it's not a superb mnemonic, but this is the only one possible. You Google it out also, there's no other mnemonic available. So must means Mycobacterium TB is aerobic. Must let. So L is going to be for the very, very famous Legionella, that is aerobic. Nagging for Nocardia. Pets for Pseudomonas. And B, breathing is a lot of things. All the B's you know, Bacilla, Bordetella, Brucella. So all of those are going to come. So repeating, must for Mycobacterium TB, LE for Legionella, N for, you only know one organism with N, that is Nocardia. P for Pseudomonas. If you want, you can take the P and S of pets, so you'll know it's Pseudomonas, it's not anything else. And B is going to be for Bacilla, Brucella and Bordetella. All of these are the ones that require oxygen. Must let nagging pets breathe. They require oxygen, but which are the ones which are obligate anaerobes, that they do not need oxygen. They will get choked by air. So how have I learned? Choked by air means they will not need any oxygen. So choked by air padho, so basically it is becoming something like ABC. ABC ban raha hai, but ABC you will never be able to learn na. With this the mnemonic you can learn. Obligate anaerobe matlab choked if they have air. They are choked by air. So C is going to stand for Clostridium. B is going to be for the bacteroids, and A is going to be Actinomyces. And now you will start realizing that some families are coming together. So for example, if I ask you which are the bacteria that make spores, you will say there is either a bacillus that makes spore or there is a Clostridium that makes spore. One more family. If I ask you which are the bacteria which are filamentous, you will say one is Nocardia which is filamentous and one is Actinomyces which is filamentous. Right now you might not know these. Why? Because you've not read bacteriology, but you will realize that whenever you have families, na, one is aerobic, one is anaerobic. Means bacillus abhi kahan pada tha? Bacillus you had studied under aerobic. So this is going to be an aerobic organism. So the other member of the family, Clostridium, you are studying over here. So that becomes anaerobic. Similarly, under filamentous, where did you study Nocardia? Must let nagging pets breathe. So Nocardia was aerobic, and where are you studying Actinomyces? Actinomyces becomes anaerobic. So many places in bacteriology, I will say, okay, this is a family, one needs oxygen, one doesn't need oxygen. That is the story that will go on. So for oxygen, must let nagging pets breathe, and for anaerobic, choked by air. Now we will say whatever is left is going to be the facultative anaerobes. These are going to be the facultative anaerobes. So Staphylococcus, Streptococcus, Enterobacteriaceae, Haemophilus, Vibrio, the remaining ones. I have not made a mnemonic for it. The remaining ones become facultative anaerobes. Microaerophilics, little bit of air they will need. How much? 5% oxygen. So how much is little bit of air? 5% oxygen. Number one, B and B. So basically, little baby oxygen they need. Okay, baby amount of oxygen they need. Baby amount of oxygen matlab 5% oxygen. So baby amount of oxygen is needed by the bacters. Also note, Mycobacterium bovis also needs baby amount of oxygen. So now I want you to recall that if Mycobacterium TB was asked, that was obligate aerobe. But if Mycobacterium bovis is asked, bovis is something which is baby oxygen. So that will need little bit oxygen. Even the Campylobacter, Helicobacter, all bacters will also need baby oxygen. So your oxygen story is sorted. If I come all the way back, guys, I have done what are the ones related to oxygen, which are the ones which are capnophilic. Now I come down to pH. The usual pH, actually they say anything between 6 to 8, normal pH in which they grow. However, of course, there will always be a variation. This is the normal pH. However, if there is an acidic pH, you call them acidophiles, which require an acidic pH. And obviously the name only tells me lactic acid wala. Lactobacillus requires an acidic pH. Lactic acid wala na acidic pH. Similarly, there is something known as alkaliphiles. Alkaliphiles are the ones which require an alkaline pH, and one very famous organism that requires an alkaline pH is going to be Vibrio. Vibrio requires an alkaline pH, very important. In fact, you will realize that you will study this. I hope you all have heard now. Vibrio causes what? Vibrio causes Vibrio cholera, rice water stools. You will realize that I will tell you a story. I'll tell you right now. They say that for Vibrio, you need to have a lot of bacteria going into your system. If few 100, 200 bacteria go in your system, you will never have a problem. You need at least 10 to the power 8 bacteria going into your system. Only then you will get infected. Why? Because guys, Vibrio is only going to be active on an alkaline pH, and the problem is that first it has to pass through the stomach. Stomach has a pH of 1, which is acidic. Most of the Vibrio get killed off over there. So you need Vibrio in too much of quantity so that some amount should at least be able to go into the intestine. That is why little bit of Vibrio never causes infection, because that little bit of Vibrio is easily damaged in my stomach that has an acidic pH. Vibrio requires an alkaline pH for survival. Let's move forward. Some of them are definitely going to require light, some of them will not. You will study one classification of atypical mycobacteria later on related to light and dark. Coming to the temperature, most of them are going to work in a medium temperature. Medium is 25 to 40 degrees, right? Most of them work under this. The ones which work less than 20, matlab less than 20 is very low temperatures, ma'am. They are psychic. They are psychic that they are working at such a low temperature. They are psychrophiles. Okay? So the bacteria that work in a medium temperature, 25 to 40, are mesophiles. The work at a psychic temperature, psychrophiles, less than 20. And the ones that work at a very high temperature, thermo. The ones that work at a very high temperature of 55 to 80, those are going to be thermophiles. I hope you know an example of thermophile. I'll give you an example. Thermus aquaticus. What does it remind you of? Thermus aquaticus reminds me of Taq polymerase. This is basically something that you have studied in the usage of polymerase chain reaction, hai na? This enzyme, that is where you get it from, Thermus aquaticus. So that is basically going to be a thermophile. It's a high temperature, 55 to 80 degree. I want to ask you something. There is also something known as psychrotrophs, which again I believe that not many students read about. Psychrophile was loving. Phile means loving psychic temperatures. That is how I've learned it. Loving psychic temperatures, low temperatures. But what are and how would you define psychrotrophs? Psychrotrophs means, yes, there is an element of low temperature over here also, but they are not loving it. Means they can grow somewhere at dual temperature. At a higher temperature also they will grow, but at a lower temperature also they are gonna grow, and that basically refers to organisms like Yersinia and Listeria. Yersinia and Listeria are the organisms which grow at a normal temperature not higher, I would say they would grow at a normal temperature. But if you lower the temperature, especially if you lower it to a 4 degrees centigrade, they start growing better. They start showing a better reaction. So they are kind of adjusting. That kind of an organism is known as a psychotroph. Grows at a normal temperature, but then grows even better if you put a lower temperature of 4. So when you go to these two organisms, please note, whenever you will go to these two organisms, you will study something. I'm not writing it because you're going to study it later on. There is something known as cold enrichment. Cold enrichment means that if I will make the temperature a little cold, they will grow better, they will get enriched. So they follow something known as cold enrichment. Okay, now moving forward, going on to the rest of the physiology and the definitions, there are quick definitions that you have to know. How are they gonna make their product? So please remember chemo. Chemo means some chemicals. So these are the bacteria that derive their energy from chemical reactions. Whenever they want energy, chemo matlab they are going to carry out chemical reactions. Then what do you think is going to be phototrophs? How will they derive their energy? From the photo. So they will derive their energy from the sunlight, from light. Okay. What is going to be autotrophs? Auto means something same, self. Hetero means something different, and litho will mean something inorganic. So let's start. Auto means that they are going to synthesize all their compounds by using the CO2 on their own. So they will make their own compounds. Auto means I am making my own food. On the other hand, heterotrophs means that they cannot synthesize their own foods. They are going to use things from the air. They will utilize CO2 and nitrogen from the air because hetero, they cannot make their own metabolites. Repeating, autotroph, they can synthesize. That's the point. They can synthesize all their compounds by utilizing CO2. Heterotrophs cannot synthesize their metabolites. They use the things from the air. And what is lithotrophs? Lithotrophs are the ones which are going to basically use the inorganic compounds. So these are some definitions, and how would they be used? You will get to know. Abhi, if you keep doing lists, it's not going to make any sense at all. You just have to do definitions. Okay, on that note, now we go on to the main part of bacterial physiology, which is the bacterial growth curve, and then we'll do a few questions. In the bacterial growth curve, you can see what are the x and the y axis. So over here on the x axis, I can see time written, and here on the y axis, I can see that there is something known as the number of the bacteria written. And how many phases? 4 phases. First, there is a lag phase. So we'll write it in an enlarged manner. What you have over here is a lag phase. Then what you go into is a log phase. Then there is a big phase known as a stationary phase. And finally, the cells have started dying. So there is a dead phase. Should we start one by one? So pehle to I know lag and log mein students have confusion. Go alphabetically. A comes first, O comes later. So first there is a lag phase, then there is a log phase, then there is a stationary phase, and then there is a dead phase. So let's start. Let us start with the very first phase that is over here. This one that I'm talking about, this is known as the lag phase. What is it? Tell me, go by the graph. Is the number increasing? No. There is no increase in number. So lag का मतलब ही यही है. There is a no increase in the number of the bacteria. Means it's the same. If there were 5 bacteria, there are still 5 bacteria. But the thing is, why are they remaining there? Why are they not increasing in number? Because right now they are doing preparation. For them to increase in number, first they will say, okay, let me get all my enzymes, my metabolites, my raw material, let me get everything together. After that, I will start dividing. So can I say they are just accumulating everything and basically becoming mota? This is all of us in the lockdown. Lag phase is nothing but you guys sitting in the lockdown, not doing any activity, not doing anything, just sitting and eating a lot of food and becoming mota. Basically, you're trying to adapt. Whatever is happening in the lockdown in the outside world, you're trying to adapt. You're staying indoors, eating food, becoming fat, and that's about it. So if I ask you a question, that maximum size is seen when? Maximum size of a bacteria is seen when? You will say at the end of the lockdown, ma'am, we were the fattest. At the end of the lag phase, there is a maximum size of the bacteria that we notice, and that is the previous year question that you have, right? After the lag phase, now it's time that your number should increase. So lag phase ho gaya. Now I go on and I see that the number is going to increase. So this is known as the log phase. Now please note, log phase means I can see the number increasing, means the cell is dividing. So tell me, lockdown khatam. Now you have to go out and work. If you have to go out and work, now will you start losing weight? Of course. So as it starts dividing, it is going to started losing weight. The bacteria is going to become smaller in size, and because it's dividing, this means it has a a lot of metabolic activity. Also tell me, go back to your pharmacology and remember, when does an antibiotic act the best, or when does any drug act the best on a cell that is dividing? So maximum susceptibility to antibiotics is also going to be in this phase. Repeating once again, this is the time when the number is increasing. Number is increasing means it's very, very active. If it's very, very active, that means that the antibiotics are going to go and kill it. Also means that because it is so active, it will start losing weight. It has become smaller in size. Now finally comes so 2 phases are done. I'm done with lag, I'm done with log. Now we move on to the stationary phase. The bacterial count has come to a standstill. Okay, so before I start with this, I want to ask you something. So for example, you were planning to do a gram staining. Okay, you were planning to do a gram staining in the previous wala also. You say, ma'am, in the previous one, all the bacteria were dividing. Dividing means they were living. No one's dead, na? All the bacteria are viable. When all the bacteria were viable, this means that on gram staining, I was going to get a uniform stain, right? I was going to get a uniform stain as all of them were living. But now as I enter this stationary phase, I will realize that some of the bacteria have basically remained viable and some of them have started dying. That is why that plateau has come. Some of them are going to remain viable, some of them are not going to be viable. So I will not get a uniform staining. Now all of them are not alive, all of them are not going to pick up the gram stain. So some will be picking it up, some will not be picking it up. So now my staining becomes non-uniform. So why has that happened? Why have you reached that plateau? Because obviously guys, till how much time will you be able to work? After some time you will get exhausted. This means that the bacteria has had depletion of nutrients. The bacteria has got exhausted, and that is why the plateau has come. So now there are some living, some dead, and non-uniform staining will come. And the mnemonic for this particular phase is, you call it stationary, na? So stat ka, I'm going to make it stab. It is a stat stab. Stab means what? If someone asks you sporulation occurs in which phase? S for sporulation, T for toxin production. Which toxin? Of course, exotoxin. A for antibiotic production, B for bacteriocin production. So remember, if you are asked in the stationary phase, sporulation, toxin production, antibiotic production, bacteriocin production, these 4 things are gonna happen in the stat stab phase. Very, very famous questions that you have, right? Now, I want to add up over here. Antibiotic production. See, the bacteria can also make antibiotics. Antibiotic production is happening in the stationary phase, whereas maximum susceptibility to antibiotics, if you are giving antibiotics, where will it go and kill? Maximally in the dividing log phase. Okay, so next question. Antibiotic production I've understood. What is bacteriocin? Bacteriocin I call as Chatur. Everyone remembers 3 Idiots, and you remember the character Chatur? What was he doing? He was a topper of the class. He used to study everything, but one day before the exam, he used to distract everyone so that no one else could study and he used to get better marks. Hai na? So bacteriocin is that only. I am a bacteria, for example. I will make bacteriocin. Why? So that I can grow and you cannot. So bacteriocin, again, as I said, there is no definition to it. So I decided to give it a definition, and that definition is Chatur from 3 Idiots. I have done my studies, but now I will distract all of you so that you cannot do your studies. So I am growing, but I will make sure that you do not grow. That is bacteriocin. You'll always remember it, right? Finally, the cells have started dying and there is cell death, or they have started involuting. So either ways, the count is going down. That is the death or the decline phase. So coming all the way back to your first thing, if I ask you questions, these are 1, 2, 3, 4 options. Where are you gonna see the maximum size? When is the bacteria most mota? At the end of the lockdown, at the end of the lag phase. Where are you gonna see sporulation? Of course, stationary phase. Sporulation, toxin, antibiotic production, and bacteriocin production. Where do you see uniform staining with gram? When the cells are dividing, I see uniform staining. But when do you see non-uniform staining, where some are living and some are dead? We finished bacterial physiology. We can take up 2 questions. You have a 65-year-old blind man living in a rural area admitted with a respiratory infection, and there is no improvement despite treatment, and the patient started showing septicemia symptoms. Radiographic images showed wide mediastinum. So respiratory infection, mediastinal involvement, bacillus anthracis along with some spores. So basically pulmonary anthrax is something that Pulmonary anthrax is something that they had put up. Now when you go later on and study Bacillus anthracis, you will actually realize that Bacillus anthracis is very famous for causing pulmonary involvement in the form of hemorrhagic mediastinitis. The most common involvement is hemorrhagic mediastinitis, and over here there is obviously respiratory and mediastinum involvement, but that's not the point over here. The point is that spores that are formed, which phase of bacterial growth curve is spores formed? How simple, I know, sporulation occurs in the stationary phase. Let's pick up one more question. There's a 9-year-old boy who was referred to the AIIMS New Delhi with a low-grade fever, cough and sore throat for 5 days. A swab was taken and inoculated into a suitable liquid culture media, and the growth of the bacteria was plotted. It's in front of you. You've got the log, the lag, the stationary, the dead. I've erased it because you guys know it. You're going to answer it now. In a bacterial growth curve, look at this. Maximum cell size, where is it? I know maximum cell size was at the end of the lockdown. That means end of the lag phase is when you are going to get this. I hope everyone's okay with this. You've done the answers, yes? Now we're going to move on to the next topic. So anatomy done, shapes done, physiology done. We move on to the next topic, that is bacterial genetics.